Here we go. 7.2 Theoretical and Experimental Probability. Go ahead and copy down these vocabulary words. You may see these on a quiz or test, so make sure you copy them. Let's talk about this real quick. Copy this down. So probabilities can be written as fractions or decimals. And if you write them as a fraction or decimal, they have to be between 0 and 1. So if you have a probability that's negative or more than 1, something is wrong there. The same thing with percents. Percents go from 0% to 100%. You can't have negative percents, and you can't have more than 100% in terms of probability. And I have this little chart here. It shows you that, if you have something that has a 0% chance of happening, that means it's impossible. Certainty is 100%. 50% means that it can happen or it may not happen. Equal chance there. And notice the numbers I used. 0% is the same thing as 0. 100% is the same thing as 1. And 50% is the same thing as 1/2 or 0.5. Okay. Here's another vocabulary word, theoretical probability. And we're going to define it as for equally likely events, so for events that have the same chance of happening. And the way we read this is, it says P of event, but the way we say that in words is probability of event. So the probability of some event is equal to the number of outcomes that you want over the number of outcomes in the sample space. So let's go ahead and just do this example. An example, we have a CD has 5 upbeat songs and 7 slow songs, with the probability that a randomly selected song is an upbeat song. So if we go by this, we're trying to find the probability of an upbeat song. So the way I'm going to write this is P of upbeat song. So this helps clearly define what I'm trying to find the probability of. So P of upbeat song. And if I just go by this formula, it says put the number of outcomes that I want. So how many upbeat songs are possible on the CD? There's 5. I have my fraction bar. And then how many songs do I have total? So when it says number of outcomes in the sample space, that's just the total number of possibilities that you have for choosing. So I have 5 plus 7. That means I have 12. So 5 over 12. And we do need to calculate this. I mean, we could say this is our answer. We could say 5/12 is our probability. Let's also just see what happens when we plug in 5 over 12. So as a decimal, the probability is 0.4167. Let's go ahead and make a note here, actually. Round all probabilities to 4 places. Round to 4 places. If you're going to give it as a decimal. So here's the probability as a fraction. Here it is as a decimal. And how do I rewrite this so it's a percentage? If you recall from the last chapter, remember how we converted percentages to decimals? Well, what if we want to go the other way? What if we want to make this decimal to a percentage? I move the decimal to the right 2 places to make this into a percentage. So as a percentage, 41.67%. So what I'm trying to say is, these are all acceptable answers. You might need to read the problem to know which way I want it, or maybe how a certain test or your end of course exam wants it. But these are all the same number, or they mean the same thing. Just it all depends on what's wanted. Go ahead and copy this down. So I tell you that the sum of all probabilities in a sample space is 1 or 100%. What that means is if you were to take all the probabilities of something in a sample space or some experiment, they should add up to 1 or 100%. And we're going to use that idea for what's called the complement. So the complement, which is your 6th vocabulary word, is the complement of an event E. It's a set of all outcomes that are in the sample space that are not in E. So the way we show that with I don't want to call it algebra, but I guess we'll call it algebra in this one. The probability of not getting E is equal to 1 minus the probability of getting E. And I drew a little Venn diagram here. You don't have to write the word Venn diagram, but You may have seen Venn diagrams before. You know, the circles. Usually you see them as the circles that overlap. But they don't always have to be overlapping. And in this Venn diagram, the S stands for sample space, meaning that this rectangle contains all the possible outcomes. Any outcomes that are possible in our experiment. E represents some result. Maybe for example, E stood for, let's say you flip a coin. Let's say E was the event of obtaining heads when you flip a coin. So then what's not E? Getting tails when you flip the coin. So if E is obtaining heads, not E should be everything that's not obtaining heads, which is getting tails when you flip a coin. So that's what all this means. So to use a complement, you do 1 minus the thing that you don't want. And I'll show you an example of how to do this. So go ahead and copy this down. I know it's a little long, but you just need to copy it down. So for example, there are 25 students in the study hall. The table shows the number of students who are studying a foreign language. What is the probability that a randomly selected student is not studying a foreign language? Now, key phrase there is not. So we're probably going to use the idea of complement here. So let's think about what we have. We have 25 students. That's key information right there. And how many students are studying a foreign language? There's 6 studying French, there's 12 studying Spanish, and 3 with Japanese. So if we add these up to 6 plus 12 is 18, plus 3 is 21. So that means that there are 21 of the 25 students that are studying foreign language. To find what we want, which is not studying, we do 1 minus the probability of the foreign language students. So we do 1 minus that. Now, we're going to have to convert 1 into a fraction. Well, let's convert it into 25 over 25. Because we need common denominators. And 25 over 25 is the same thing as 1. 25 minus 21 is 4. 25, you don't subtract the denominators. You just keep the 25 as your denominator. And here's your probability. As a decimal, again, what do? You do 4 divided by 25, which is 0.16. So this is also an acceptable answer. Or what is that as a percentage? That'd be 16%. So there's a 16% chance that if you were to randomly select a student from this study hall, they would not be studying a foreign language, which seems reasonable. It seems like most of the kids are. That's a pretty low percentage for those that are not. All right, we have a few more vocabulary words. We have trial. A trial is an experiment for testing probability. And then we have the other namesake of this video, experimental probability. And that is the number of times, I obviously don't know how to do plural. I'm not an English teacher, apparently. The number of times the event occurs over the number of trials. So whatever you get over how many times you do the thing you're doing. So for example, before I do this example, like let's say you're flipping a coin. Let's say you flip a coin 10 times. Let's say you obtain 4 heads and 6 tails. Let's say you wanted to know how many times did you get tails. You would do 6 over 10. Because 6 would be the number of times the event occurs, and 10 was the total number of trials. So let's go ahead and do this problem, this example. We have the table shows the results of drawing 1 card from a deck, recording the suit, then replacing the card. So we did it. We got 5 hearts, 9 diamonds, 7 clubs, and 5 spades. So let's see how many times we flipped total. Let's just add up 5 plus 9 plus 7 plus 5 real quick. That would give us, 5 plus 5 is 10. 9 plus 7 is 16, so we did it 26 times. So that means that in this experiment, there were 26 trials. They did the drawing 1 card 26 times, recording the suit and replacing the card. So we're going to find the experimental probability of drawing a diamond. So how many times did we draw a diamond? We drew it 9 times. So all we do is, and let's use the proper notation here. P of diamond equals 9 over 26. And you can keep it like that. Again, You can go to your calculator if I want it as a decimal or as a percentage. I'll try and let you know when I want what, if I want a fraction, a decimal, or a percentage. But it should be pretty easy to go through each one of those. All right, here's the last slide. This is pretty fast today, so this is a classic probability problem. This is the marble problem. If you have a bag of marbles with 4 red, 5 blue, and 7 yellow, find the following probabilities. So we're going to find all 4 of these. Notice again, I'm using that notation, the P. So you just read it as find the probability of getting one red marble. So let's go ahead and find out how many marbles we have total. That'll be 4 plus 5 plus 7, which is, let's see, 9. So that'd be 16. So we have 16 total. How many red are there? There's 4. So the probability of red is 4 over 16. That's really easy. Because there's 4 red, 16 total. Let's find the probability of it not being red. So this is where we can use the complement to help us out, do it a lot faster. So for not to be red, we just do 1 minus the probability of it being red. Which means I do 1 minus, well, I found this in part A, which is 4 over 16. Let's use some equal signs here. Now, let's convert 1 into 16 over 16, minus 4 over 16. 16 minus 4 is 12. 16 stays. Reduce the fraction to 3 over 4. So there's a 3 over 4 chance of not drawing a red. All right, now these two are a bit more complicated, so you need to just follow my logic here. Find the probability of drawing a red, then a blue, and it says with replacement. And what that means is, let's say, okay, you have the bag of marbles. Let's say you draw a red one out. You look at it, okay, I got it. And it says with replacement, it means you're going to put it back, and then you're going to draw another one and see what's the probability of now finding a blue one. So every time you go to draw, the number of marbles in the bag is always going to be the same because you're replacing your draw. So let's go ahead and find the probability of red real quick. Actually, we already have it, 4 over 16, which, I just realized that we did not reduce. It's 1 over 4. My bad. So the probability of it being just red is 1 over 4. Now, what's the probability of you putting that red one back and now drawing a blue one? Well, how many blue do we have? We have 5. So the probability of finding a blue one is 5 over 16. What do you do when you have 2 different probabilities that are part of the same problem like this? What you do is you go ahead and multiply the 2 fractions. So we're going to take 1/4 and multiply it by 5/16. And let's just see what we get. Remember, with multiplying fractions is very easy. You multiply the numerators, so that's 5 on top, and you multiply the denominators. 4 times 16 is 64. So that's a chance of you drawing a red and then a blue, assuming that you put the red one back the first time. So what does it mean when we find the probability of red then blue without replacement? What it means is after you draw the first marble, don't put it back. So that means on your second draw of the marble, you have less marbles than you started with on the first draw. So let's go ahead and let's just go through this in a logical way. I'm going to switch colors one more time. What's the probability of red? Well, again, we saw that it's 1/4. But now you're not putting that red one back, or whatever marble you drew. So now we're down. If we had 16 total, but we're not putting this back because it's without replacement, we have how many total now? We have 15. So to find the probability of the blue one, we have to put 15 on the bottom. That's our new total of number of marbles. But how many are going to go? What's the number that's going to be on top here? Well, because let's assume that we took one of the red ones out. Did that change how many blue marbles are in the bag? It did not. So how many blue marbles do I still have in the bag? I have 5. So then I take these 2 fractions and multiply them. 1 times 5 is 5. 4 times 15 is 60. And we can reduce this. 5 goes into both of these. 5 goes into 5 one time. 5 goes into 60 12 times. So our probability of red than blue without replacement is 1/12. Okay. So that's the notes. A couple shout outs. Okay, here we go. Sugar Rose. You know who you are. The shout out period 5. They really did good today, and they wanted me to shout them out. And Raina, because, she does a great job. And I just want to thank you guys. Last unit went great. I'm very happy with everyone. Everyone's effort, and just keep it up. Oh, and sorry, math joke. Here we go. Crap. I want to make sure I say it right. Okay. Did you hear the joke about the statistics teacher? Probably.